Verilog series. We are going to discuss creation of full ladder using gate level modeling. So in previous lecture we discussed how we can design a full adder using data flow modeling. So previous lecture. So today we are going to discuss how to make it using gate level modeling. So in gate level modeling we use primitive gates as I said. So we will just assign our ports A, B, C in, some, C out. Much fine if I just in 1 second. Uh, mm, Input here. Let me just do input here, input here, then output here, and the last output here. So by default, these all are wire types which we do not declare them. These all are wire types. So let us go through the diagram which we need to replicate. This is the full diagram of a full adder consisting of a two half adders. Now, what we desire is we have already A, B, and C in. We need additional wire, so this wire, which is the XOR of A and B, this wire, which is the AND of A and B, and this wire, which is the AND of A XOR B, A, and C in. So once we get these three wires, that is, let us name them as P, Q, and R, we will get our answer easily. So let us move ahead. Declare some wires. Wire P, Q, and R. Now we will start assigning them. Sorry, we will not do assigning. We will use the gates. So we just use XOR. Let us name it as X1. X1. 1 second. Uh, so XOR X1. So we will just give the input. So we set here as P and XOR of A and B. I just told this P is XOR of A and B. A comma B. Then again we need what this Q, which is A and B. So AND of X1 X2, which is Q, that is A comma B. And for some we need this XOR of A and B. So we just assign this XOR uh, X3, let us name it as. So I just gave some, that is XOR of P comma C in. So we created the sum here. Now we need a C out. For that we have a AND here. Uh, we completed this, we completed this, we completed this. Now we need this. So this is AND of what? A XOR B and C in. Okay. So AND of, let us say, X4. We can name it as R. Okay. So we give R XOR of A, sorry, AND of A XOR B and C in, C in. And lastly, in order to create a C out, we just need a OR gate to OR this with C in. OR gate X5 with what? C out. We have a R and a C in. So we created a C out also, and that's it. We completed our program here. Let us save this file first, then we will see the schematic that is created. I guess file is saved now. Now we are going to here as open elaborated design and we will click on schematic, then OK. It is creating the elaborated design. So finally our design is created which we intend to draw. Uh, 1 second, we have only, I guess we missed some gates or what. We only created no, we have a two AND gates here. Why it only created one AND gate? Um, X4, it created X4 only. Where is this X2? Q, that is A and B. It did not create the schematic. 1 second, I need to check. Uh, did I did something wrong here? So it is Q, that is A and B. We have a wire Q, that is A and B. We Where is this wire? A and B. This one is X4. X2 is Q, A and B. Why did not come out as expected? We have a XOR which we wanted, but we did not get this PQR. We have A and B and inputs and outputs XOR sum and B. I guess since we did not tend to use this is Q, I knew that we were supposed to do Q here. This is Q, so here we will get Q. So let us reload the design. So our new design is created. We have A and B here, so which we name as X2, X1, X3, X4 and X5. All of them X1, X2, X3, X4, 5, all of them are created here. So this is what we intended to draw, a half adder here, the half adder here, and the last is this creating the C out. Now we will go and create a test bench for this to check whether the output is coming or not. So we'll use test bench. We just finish. We don't need to assign any module for now. Input ports, sources. 1 second, it is taking some time. Go in simulation sources, sim. Click on the test bench. Uh, just give reg type as A B scene wire to some comma C out. Then we will do full adder instantiation, full adder, and then we will do design under test. Now we will connect the ports dot A to A, dot B to B, dot C to C. Sorry, C in to C in. So we let me check the order here. We will close this file. A B C in sum C out. A B C in dot sum to sum and dot C out to C out. And now our half work is done. So we will create the initial block and start creating the output initial, begin, and here we'll just do what we will call display here. In the display we will show the value of a, b, c in, then sum, c out. One second, here is the double quotes. Now we'll do monitor. uh, let's not print the time. I don't need to print the time every time. I don't have time. So let us just do a equals to percentage b, b equal to percentage, sorry, percentage b, b equal to percentage b, c in equals to percentage b, and then we have sum equals to percentage b, and c out equals to percentage b. Now we will just give a, b, c in, sum, c out. Let us use some tabs here. That should be fine. If we see, now we have created. Now we will just assign for few seconds that c in is equals to 0, and corresponding, let's say for first 10 seconds we have a equal to 0, b equals to 0, then next 10, a equals to 0, b equals to 1. For then for the next 10, we have a equals to 1, b equals to 0, and then for the next 10 we have a equal to 1, b equal to 1. So we created this. We will just replicate this block, and now this time I will assign c in as 1. So after, let us say, 5 seconds, I am assigning c in as 1. So initially c in was 0, the corresponding that these values will be printed, and now the c in is 1, corresponding those values will be printed. Now we will just do finish. Let us say after 3 seconds I call this finish. So program for test bench is completed. Just need to save this file. We just minimize this. Here in the simulation we will go and press run simulation here. Now here our simulation is created, but before, let us go through the console here and see the corresponding values. So a b 0 0, sum is 0 0 1 1 1 0 1 1 1 0. Now here we have starting 1. You have 1. Here is also 0 1. 1 0, and c in is 1, so sum is 0, and c out 1 1 1, so 1 and 1. So this was last. Why it came out of nowhere? This line is okay. This line came out of nowhere, but we didn't want it. So it is giving the correct output. Let us go in the same schematic. Sorry, waveform. Let us check the waveform here. For the below 10 seconds there was nothing, so at 10 it was all 0, at 20 it was 0 1, so sum will be 1, here 1 1, so sum is 0 and carry. Now let us click here at the c in. The c in from here it is 1. So after 45 seconds or what, so here c in is 1, so all three are 1, the sum is 1, and c out is also 1. So let us see here, a and b is 0 and c in is 1, so sum is 1 and c out is 0. So our program is completely working fine. So we created a test bench for full adder using gate level modeling. uh, we last discussed data flow, and now today we discuss the gate level modeling. Although data flow is easy, we use gate level modeling in some cases also, but I prefer mostly the either data flow, behavioral modeling. Gate level modeling I prefer very less. In some cases, if you want to create a deep flip flop or very complicated circuit, you can just for ease you can assign these, but that's it. So we created a test bench, so we see how to create a test bench. We assign input values here, and after 10 seconds, 5 seconds, we got C in changed, and then we checked the console and we got what we expected. Where is this console? So we got in the console which we accepted the value. So if you want to study more, you can connect through us, and you can follow me on GitHub also. GitHub. I will provide the link, and also I have a Telegram channel. You can join my Telegram channel also. In the channel main page, when you will go, there will be a click on the main page. So you can just click there and join my Telegram channel. Inside the Telegram channel, I have given the link of GitHub. In GitHub repository, I am adding these codes, and you can access my codes. Let me show you. So this is my GitHub repository which you can access. You can come here, check for the combinational circuits, finite state machine programs, and sequential circuits. Created some sequential circuits here which you can access if you want to practice. I've given some combinational circuit. I created a 32-bit adder using 16-bit adder. You can come here, check for the combination circuit. I am adding more and more circuits, so don't worry. We have a priority encoder, 4-bit look ahead carry. We will create all these in the upcoming lectures, so you can access this my GitHub repository. My name is Harsh123. You can just check for my username there, you will get, and you can follow and give a star to my GitHub repository. Thank you.